This looks to be a fairly standard projectiles question. With projectiles questions like this, you need to consider the horizontal and vertical components of the motion separately, but use the one thing that links them to allow you to solve the question. So the one thing that links the two two different horizontal and vertical motion parts is the time. So they both take the same amount of time. That's what links them. So we're told that the projectile launched from the ground with a speed of 25 meters per second at an angle of 42 degrees to horizontal. So we can work out from that how long it takes the projectile to get to its maximum height, or we can work out how long it takes to get from its all the way back down to having the same velocity in the opposite direction. So it's using the symmetry of the motion. So we can do it and solve it in terms of the symmetry of the motion, where I can work out when, at what time does its vertical motion stop? So what time does it reach its maximum height? And then that's half of the horizontal distance. Or I can work out at what time does the vertical component of velocity equal the negative value of its initial value. So it'll start off positive and then it'll end up negative, and after that time, that will be the full time period, and I'll work out the horizontal velocity from that. I'll work through that then. So we've got 25 meters per second, and then at an angle of 42 degrees to the horizontal. So the vertical component is sine 42, so we can work that out. It's 25 sine 42. So the vertical component, which I'm going to call Vy, is 25 lots of the sine of 42. So sine 42 and then multiplied by 25 gives me 16.728 meters per second. Okay, and then it's for the vertical motion, it's acted on by a uniform acceleration, which is due to gravity. So if this is positive, then gravity is negative. So I can work out the time. So I could go v equals u plus at. And if I go for the full motion, then I'm interested in when the v value is the negative of u. So you end up with this. So you end up with negative 2u is at. So the t is negative 2 lots of 16.1628, etc., all divided by the acceleration, which is 9.8, and it's negative 9.8 because it's down and this is up. So times that by 2, divide by 9.8, and we can see how long the full motion takes 3.4139, etc. seconds. So that links the two. That links the horizontal and vertical motion together. That time is the same for both. Then the horizontal motion, v horizontal, is 25 cosine 42. Oops, 42. This will be similar because 42 degrees is near to 45. So the cosine of 42 times 25 gives me 18.5786, etc. meters per second. Then the distance travelled, the displacement in the x direction is just v times t, because the velocity is constant in the horizontal direction. So it's 18.57, all that stuff, times 3.4 times 3.4, and we get 63 meters.